This is a video review of Chapter 7 of Data Modeling Made Simple by Hoberman, entitled, What Are Keys? Think about a database table with thousands or tens of thousands or even millions of rows of data in it. We've got to find some way, we've got to have some way to get to those rows and to be able to grab the rows we want. Those are things we call keys. A key is a data element or elements, because it can be multiple elements, to help us find a specific entity. There you go. Very simply, that's what a key is. Now, candidate keys are one or more attributes that uniquely identify an entity. Okay, a candidate key is one or more attributes that uniquely identify an entity. For instance, let's think about a table of students at a university. Maybe we've got a list of all the students that have ever been at the university. What are some of the candidate keys? Well, Social Security number would be a candidate key because uh, no two people are supposed to have the same Social Security number, so that would work. Could we concatenate someone's last name, first name, middle initial, and birthday? Would that uniquely identify a student? Maybe. I guess there could be a chance of two John J. Smiths born on the same day. Um, what other kind of candidate keys could we use? Well, we could use a student ID number, which is a special type of key called a surrogate key, but we'll talk about those. So there can be more than one set of candidate keys. So when you're going through looking at data, at a set of data, at a table of data, you may see more than one way to uniquely identify each entry. You may have to concatenate some columns together, some attributes together to make that work. But be sure that you understand all of the candidate keys. Find all the different candidate keys you can come up with, because we're going to use the one best candidate key to become the primary key. Before we do that, though, let's look at the four properties of a candidate key. A candidate key needs to be unique. So whatever the attribute or group of attributes together must always only point and must only apply to one entity, one row. It needs to be non-volatile. A non-volatile means that it needs to not change. So using someone's cell phone as a candidate key isn't going to work, because what if you change cell phone numbers? Um, some people do that sometimes. So that's not going to work. Now, is the cell phone number a key? Yes. Can you use it to find somebody? Most of the time, yes. But it's volatile. It can change, like using an address or a zip code. Yes, it's a key, but it's not good for a candidate key because someone could move. Now, candidate keys need to be minimal. So in the previous slide I mentioned we could take last name, first name, middle initial, and birthday and jam them together, and that's probably a candidate key. Is it a minimal candidate key? Is it as simple as possible? No, it's not a minimal candidate key. So we can ignore that one, just set that one aside. And lastly, a candidate key must be not null. Now, Hoberman lumps not null into number one, unique, but I want to separate it out and talk about what null means. Null means having no value. So, what if you have a field, an attribute, a data element called cell phone, and the person doesn't have one? There are people that don't have them. Well, what you would put in that field would be the null value, saying there is no cell phone. There is no value to that field. So we cannot use null values in candidate keys. We can use them as keys, but we cannot use them as candidate keys. So a candidate key must be unique, non-volatile, minimal, and not null. It must have a value. So what we're going to do is we're going to choose one of the candidate keys to become the primary key. We're going to pick one of the candidate keys to become the primary key. It should be a simple candidate key. It should be a candidate key that makes sense. It should be secure. In other words, to use the Social Security number as the candidate key in a table, probably, or in the primary key in the table, is probably not a good idea because we don't want Social Security numbers all over the place. So we should make sure that our primary key is simple and secure. Now, it may be a concatenated key. You may have to concatenate 2 fields together or 3 fields together to get that primary key, but it will be simple. It will make sense. You will understand why we did it. It won't sit out like, why in the world did he do that? There's this over here that was so much easier. Every table must have, every entity must have a candidate key defined as a primary key. Every table, every entity must have a primary key. Can't do it without a primary key, or we can't do all the data modeling and we can't do all the relationships the way we want to. And lastly, a primary key may be a surrogate key. Let me describe a surrogate key to you. For instance, let's look at the student database, the student table again, where Social Security number would be a primary key. It's a candidate key. It would work. It's not secure. It's not real pretty, but it would work. But what we've done instead is we have created a surrogate key. We've just said, well, the first student is number 1, the second student is number 2, the third student is number 3, and you're probably student 200,000 something. And every new student just gets the next number. Every new student just gets the next number. It's not a natural key. It's not a value that you have with you naturally as a student. But it's a value that we have assigned to you and has become your key in our system. So we may create a surrogate key. You may come along and say, well, the candidate key here is a mess, and this candidate key here is ugly, and this candidate key here is not secure. I'll just create a number column. I'll just create a surrogate key, assign them 1, 2, 3, 4, A, B, C, D, E, F, and everything is groovy at that point. So that is something you can do when you're designing your database tables, especially if your surrogate keys or your candidate keys or your primary key would be a long string of text or something of that sort that just doesn't make sense. It's not simple. Sometimes a surrogate key is what you need. There's another type of key called the foreign key, and a foreign key is the primary key of one table that appears in another table as a data element. Let me say that again. A foreign key is the primary key of one table that appears as a data element of another table. That's called a foreign key. We use foreign keys to implement one-to-one relationships and one-to-many relationships. Basically, we take the primary key of the one table and put it as an attribute or a data element on the many table. This will be a little confusing initially, but you need to really commit this to memory. A foreign key is the primary key of the one table added as an attribute to the many table, and it's how we implement relationships. You need to commit this to memory because this will come back and haunt you if you don't understand what a foreign key is. It's a primary key of the one table as an attribute of the many table, and it's used to implement the relationships. Let's see an example of that. So here we have two tables. I have a table called the vehicle table and a table called the owner table. Let's just think of this as a subject area model now. Let's not worry about the attributes at first. Let's make sure our cardinality is right. An owner can own 0 or more vehicles. A vehicle is owned by one and only one owner. Okay. An owner can own 0 or more vehicles. A vehicle is owned by one and only one owner. Above, you can see some owner data with the owner number, name, birthday, license number, license state. Take a look. The primary key on that table is underlined, and I marked it with the letters PK so that I know that's the primary key. Owner number looks to be a surrogate key, doesn't it? Just 1, 2, 3, 4, 5. Well, that's kind of interesting. Why didn't you use the license number, their state issued ID number? Well, because that's volatile. What do you mean it's volatile? Well, what happens if Jim moves from Kentucky to New York State? He gets a new driver's license, gets a new driver's license number. You're right, it is volatile. So that would cause all kinds of problems, wouldn't it? So I, instead of, and I could have taken their birthday or their social security number or lots of other attributes, but instead I just kind of said, well, let's create a surrogate key. Let's just assign them the numbers 1, 2, 3, 4, 5 all the way up to however many owners we have. And you can see the data there of Jim, Bob, Sue, and Mary. Now, let's come over here and look at the vehicle table. On the vehicle table, I've chosen the vehicle identification number, VIN, which is that number on your dash under the window. You know, that number that's on your car. If you don't know what it is, go look for it. You'll find it. The manufacturer put that number on it. That number is unique for every car ever made. There will be no two cars in the history of the planet Earth that will have that same number as your car has today. All the manufacturers in the world have agreed to it. That's what they're doing. So that vehicle identification number is unique. It's a big number, but it's not complex. It's not that difficult. Do you care if someone knows the VIN of your car? No, because you can walk up to a stranger's car and just peek in the window and it's right there. So it's not something you've got to hide. It's not something you keep under lock and key. So that would make a good primary key, wouldn't it? So now my VINs here for my 5 vehicles are shortened. 1A, it's a Chevy Silverado that belongs to Jim. Notice that the owner ID exists on the vehicle table as a foreign key. So that by pulling up a vehicle, you grab a vehicle, and then you go over to the owner ID, and then you jump over to the owner table to get the owner's name. See how you would go from here and jump the link over to get the name. So the Chevy Silverado is owned by Jim. The Chevy Cruze, the 1B, is owned by, Jim owns 2 vehicles. The British MG, which I happen to have one, I love it, but the British MGB is owned by Bob, because you can see that Bob is the foreign key that relates over to the owner table. The Ford Edge is owned by Mary, and the VW, the Volkswagen Thing, which is another fabulous old classic car, is owned by me again. Yay. So you can see that I own 3 vehicles. Bob and Mary owned 2 vehicles, and Sue has 0 vehicles. So the cardinality is exactly correct, that an owner can exist with no vehicles. A vehicle can have one owner, an owner can have multiple vehicles, and you can see that the data all works with this primary key, surrogate primary key on the owner table, a natural primary key on the vehicle table, and a foreign key on the vehicle table. This concludes our brief discussion of keys. I hope you found it helpful. I'd like to say thank you for watching. Remember, this video is copyright 2020 by James M. Renault, PhD. All rights are reserved.